How do we design practice to build math thinking? Practice is really important, but how often do you see students going through a worksheet, going through 15 or 25 problems, and then they get to those two-story problems and ask, what do I do? Do I add? Do I subtract? Do I multiply? Do I divide? Happens all the time. So what's happening is that the kids are practicing the skill, but they're not connecting it to then using that idea to solve a story problem, to build understanding. I'm Dr. Jonathan Brendifer from the Developing Mathematical Thinking Institute, and today our DMT Insight is going to be on varied practice. The problem is not that practice is bad, it's how we practice. So we're going to start with Notorious. This is first grade, second grade with a compare problem. So let me give you an example. There's 58 green apples and there's 36 red apples. How many more green apples are there than red apples? Kids' hands go up. What do we do? And typically with that problem is they either just say, oh, it's 58, because they're thinking, oh, it's 58 green apples, or they just add the two together. They don't look at the comparison and subtract. Okay, so one of the solutions that we came up with, so we have what's called the DMT 3-column varied practice worksheets. They're very powerful. Let's talk about what they are and why. Okay, so we have that first story problem that I just gave with the compare problem. So that's in the first column. Then in the second column, we're going to have the iconic model. So they have to build, usually using like a number line, a bar model, an area model, or depending what other types of mathematics that you're working on. So in this case, we would want to have the bar model with 58, you have a quantity of 58 green apples. Then right below it, we're comparing, so we have them start at 0, the same place, and we have 36 red apples. That's going to be, I like to talk to the students where, well, 58, 36, maybe it's a little bit more than half, so we're going to proportionally build that bar model, that rectangle, to be a little bit more than half. And then we're going to draw a little line here between the two, and that is going to be our question. How many more green apples? And then we can see, oh, the visual's getting us to have the image of 58, 36, and what is the difference there? So we're going to be subtracting that amount. Then the last column, we're going to actually solve it using whatever symbolic model that we're working on. So 58 minus 36, and then we're going to do that subtraction to get 22. But now, the next problem is we're going to give a comparison in an iconic model. And then the story is still going to be about apples, but they have to write their own story. That is what is absolutely amazing. When kids start, they have to make two statements with the green apples and red apples. Then they have to come up with, what is the question? What do I need to ask? What's the words? And that gets them really think. That's what makes a compare problem versus a part whole problem versus a join versus a separate problem. And then they're going to solve it using the equation. And then the third column, they're going to give the equation. It's already there for them. And sometimes we actually use the language there, like we're composing something, we're decomposing. And then they have to generate the iconic model and they have to generate a story. And we're going to keep it all about apples in this case. So we don't want them to go off on different topics, because they will. They'll start writing about dinosaurs and all kinds of other things. So we'll keep it really simple for them. And then we can do the next set of problems. And what we like to do is we create these worksheets, and then we can have easy problems, a set of easy problems, and then we could do medium, and then we can do some extension problems. So it's really nice to differentiate with the kids that are struggling or the kids that are more advanced. So why does this work though? This is the power. So Pavio in 1986 talked about there's these two pathways. He calls it dual processing. And there's verbal and nonverbal. The nonverbal is imagery. So in our case in mathematics, it's more spatial reasoning. It's the number line, the bar model, the area model, it's the graphs. It's visually seeing it. And then the verbal, which is more linguistic, which is the story problems and also the equations too. So one of the things we do with this worksheet then is it goes from the context, the verbal, to the imagery, the visual, and then so that helps connect the two together, building really resilient understanding of mathematics, true understanding, and then we connect it with the symbolic so it sees it, where is it in the story, where is it the visual. So our brain then has such durable understanding. So then kids have that ability to then remember things long term because they truly understand it, and they end up liking mathematics much more. So With the dual processing, there's a couple other things. We also talked about, we have a DMT Insight on Bruner's work on enactive, iconic, symbolic, which is really powerful. Now, in this case, we're not doing the enactive, the physical manipulatives. You could generate that if you're in kindergarten first too, in a different type of worksheet. So we do more with the symbolic context, the iconic, and then go back to symbolic. So that's really powerful there. It also highlights Hattie's work. We talked about that, where visible learning. And so this really is an example of why that is so powerful. So to end here, kind of the takeaways or the 3 benefits that you get are, you get that deep conceptual understanding. So it's not just the procedural, you're understanding the concepts, how they work, why they work, and connecting it to real life situations. You're also getting kids to have metacognition. They're thinking about the story problem, the equations, and the iconic models together, which actually builds better schemas. So then they actually have durable understanding, which then leads to flexible understanding and transfer of ideas over time. So now they can take these ideas, not only remember them, but now also transfer it to new situations as they're learning mathematics. So much more powerful, and how freeing it is for the kids to have that understanding and feel, I actually get mathematics. A benefit for the teacher, if we're only doing those worksheets where it's 15 to 25 problems, usually symbolic, and they try and do the story problem, where then the kids are stopping, asking questions, coming up to your desk, very inefficient time, and it's frustrating for us as teachers getting all that information. You start doing the very practice sheets, you start seeing the benefit right away, where kids are actually getting the understanding. It's so much more efficient for you, and over time you see the benefits for, yes, the kids, but also for you as a teacher. Okay, I'm going to put in some examples of first grade, third grade, and fifth grade. So we're going to put in a companion document that shows you some examples that you can try out. I really hope you try this out. You're going to find it absolutely fabulous. You can also come to our website. We have a lot of our intervention activities. Use the very practice sheets, dmtinstitute.com. Please share this with others, follow us, and like us.